All right, what is up, people? We are doing the Chapter 7 test review. Hopefully you enjoy the frozen placement underneath. That's what you get when you have two girls here. So, all right, here we go. Chapter 7 test review. First question, find the value of x round to the nearest tenth. We're going to have x be two things. Well, let's start with this, and then we'll call this z. We'll do both. So just in case you found x to be the angle or the side, we will rock both ways here. So first up, if x is the side, you're just going to use Pythagorean Theorem. So 20 squared. Remember the formula. Let's do this real quick. We have a squared plus b squared is equal to c squared. That's when you're using looking for the hypotenuse. In our problem here, we're working for a leg. So we can also use the formula c squared minus b squared is equal to a squared. Or if you want to do c squared minus a squared is equal to b squared, both are fine to use. So I'm going to use this formula. So I'm doing c squared minus the leg squared, which is a squared, is equal to x squared. And then we're just going to square it out. So this is 400 minus 64 is equal to x squared. And then when we work with this, we're going to 336 is equal to x squared. And we're going to take the square root. Now, on your calculator at this point, okay, if you do menu on the calculator page, 23, so menu for algebra, or menu, then number, and then factor, and then you can just type in 336, hit enter, and it'll spit out your factors. In this case, are 2 to the 4th times 3 times 7. This 2 to the 4th is really 4 2s. So if you want to think of this as 2 times 2 times 2 times 2, 3 and 7. So these 2's are going to come out. This is how you do simplest radical form. You're going to get 4, and inside is 3 and 7, so that's really just 4 radical 21. So that's simplest radical form. This does say nearest tenth, so we do want to round this off. So just wanted to go over both, so we kind of have an understanding of how to do both, just for review. And then when I do this one, you're going to get to the nearest tenth is going to be 18.3. Now, if we're doing Sohcahtoa, right, so I'm looking for the angle here. That's 820. We're going to first look at our angle, and we're going to label our sides. So 8, remember, two sides of an angle is Sohcahtoa. All side lengths is Pythagorean Theorem, so that's how you can tell the difference. So from here, this is the opposite side. That's my hypotenuse, okay? So I know if I do Sohcahtoa, so I write it like this so that you can see the ratios, or if I'm going to write SOH, you can remember how to do it that way. So it's up to you. So just let it go on that point, all right? And then what we're going to do now is do, in this case, the sine. So the sine of the angle, we're using this because we're using O and H, is equal to the opposite side over the hypotenuse. Let me plug in. The sine of z is equal to h, or 8 here over 20. And from here, we're just going to do the sine inverse. So the sine to the -1, that's really pronounced sine inverse of the sine of z. And then we put the sine inverse over this. So we cross out the signs. We're left with z equals. And then on the calculator, we just hit trig, sine inverse. We enter our fraction. So we enter in 8 over 20. We go ahead and hit enter. And we get, in this case, 23.6. And this is degrees. So depending on how you're working, that's essentially how you're going to walk through Sohcahtoa. Oh, I'm going to show you this. That's Sohcahtoa, so you can see it up there. All right, and you should be good to go. Okay, on the next one, we have 3 side lengths, so we're going to use Pythagorean Theorem. We're looking for a leg, so if you want to use a squared plus b squared is equal to c squared, you are more than welcome to. Okay, I'm going to use the c squared minus b squared equals a squared. So we're going to do 13 squared minus 5 squared is equal to a squared. This just moves this over in one step. That's all it does. So this is 169 minus 25, all right, which is 144. And then if we square root 144, we're going to get 12. And that's the length of A. Nearest tenth, it is straight up, so really just 12.0 for rounding the nearest tenth. That would be it. Okay, number 3, classify the triangle with sides 6, 9, and 10. So with 3 sides, it's a couple things. Number 1, if it's equilateral, they should all be equal. If it's isosceles, you should have 2 are the same. So obviously this one is out because there's none of the same. But to make it scalene, that's not one of the choices. So the options are acute, right, and obtuse. And if you remember, we talked about the fact that you can use the Pythagorean theorem. So for acute triangles, if you do a squared plus b squared, this should be greater than c squared. So the way that I remember this is that if the A side wins, it's acute, A and acute here, okay? Right means that a squared plus b squared is equal to c squared, right? So these are equal. And obtuse means that the c squared side wins, that the c squared is bigger than a squared plus b squared. So if it's equal, it's right. If the a side's bigger, it's acute. And if the c squared is bigger, it's obtuse. So here we're just going to do 6 squared plus 9 squared. We want to check to see if they're equal. We're not sure, so we put the question mark over it. And then 10 squared. So this is 36 plus 81. We don't know if it's equal to 100. And then we can kind of easily get the idea here. And we add 36 plus 81. We are going to get amount that is greater than 100, which is in fact 117. So now we know they're not equal. We'll throw the greater than symbol in. All right, and it's greater than 100, so that we know it's acute. If we needed to explain, we would say this is acute because a squared plus b squared is greater than c squared, and we'd be good to go. All right, write the ratio for the sine of A. So figure out A. We go opposite. We go adjacent. We go hypotenuse. We know the sine of the angle is equal to the O over the H from Sohcahtoa, right? So Sohcahtoa. And then we just plug in. So the opposite of A is 4. Okay, so the sine of A is 4 over the hypotenuse, which is 5. And boom, there's choice C. All right, going on to the next one. All right, for number 5. If the ratio of the tangent of 26 is A over 6, A represents what part of the triangle? And so just remember, the tangent of the angle is equal to, just like we have over here, the opposite, right, leg over the adjacent leg. So here, the top part is the opposite, so that's what we're going with, okay? And actually, opposite, yeah, this, we could also go with the leg, but I would go with opposite here, so interesting question there. All right, the next one, if the tangent of A is 0.268, how do we solve for A? Remember, we take the inverse, or the arctangent, if you're using that one, okay? If you want to put down arctan instead, so arc, A-R-C, wow, I should spell here, tangent, that's another way you can write that, okay? And then these two cancel themselves out. We get A is equal to, and then we just bust out the calculator, so trig, I'm going to get this pop up here. So trig, there you go. Tan inverse, and then 0.268. We hit enter, and we get 15.0027160208, and obviously that is closest to 15. Page 1 done. Okay, I'll post the answers as well. Give you guys those tomorrow on the worksheet so you guys can check them out. All right, solve for D. So the sine of 52 is equal to D over 32. Here, remember, when you're looking for a side, we cross multiply. So D times 1 is equal to D. And then there's this 32 times the sine of 52. So D equals, on your calculator, just 32. And then trig, you can do sine, and then 52. And we're all good to go. And here we're going to get 25.2163441154. Technically, if it doesn't say what they're round to, you should write out the entire number. Don't stop short, no significant figures. Just write it all out, okay? Number 8, same option here, stop with the variable, round to the nearest whole number. So once again, two sides in an angle, that's Sohcahtoa, okay? You could also use the law of sines here with a 90-degree angle. We'll stick with Sohcahtoa. So Sohcahtoa. Here's my angle. That's the opposite leg. This is the hypotenuse. So the sine of A is equal to the opposite, which is 8, over the hypotenuse, which is 12. And then I'm just going to do the sine inverse of the sine of A, or arc sine, right? And that's equal to the sine inverse of 8 over 12. So A is equal to, calculator time, trig, right? Sine inverse, okay? And then we just do the fraction. So 8 over 12, hit enter. And here we want nearest whole number. It's 41.8103, which is approximately 42 degrees. Okay, calculate the length of side C. Up next. So in this case, same thing. Here we can use the law of sines, 70, 90, which means this is 20. So we could do like the sine of 29 over 17. We'll just do Sohcahtoa again since we're working on that. So once again, this is the opposite side. This is the adjacent leg. It's the opposite leg, adjacent leg. So we're going to use tangent this time. So the tangent of 70 is equal to the opposite, which is C, over the adjacent, which is 17. Whenever we're looking for a side, we cross multiply. So C is equal to 17 times the tangent of 70. Now, if you put the whole number in front, that will help prevent problems when you do your calculator and you do 70 times 17, the calculator doesn't think you want to multiply this and then do the tangent. So if you make sure you either close the parentheses first around the 70 or put the 17 in front, and then you don't have to worry about that problem, okay? So just be careful with that. So if we're doing the calculator here, we do 17 times the tangent of 70. Go ahead and hit enter. And here we get the length of side C. So we're going to get 46.70711611307, and that's equal to C. Okay? Should round. If you round to something nearest 1/1000th, it'll say what to round to on the test. All right? Find the variables in each one. This is a 45, 45, 90. It may not look like it, but it is. If you remember the rules for a 45, 45, 90 we went over in class, okay? You can just keep in mind that if this is 3, right, we talked about if this is X, right, let's use a different letter. If this is C and this is C times radical 2, 40, 45, 45, 90. So knowing those rules, you would just label, right? If this is Y, this is also Y, and this is Y radical 2. So labeling your figure like this or drawing a triangle with the label is showing work. So then I can just say Y is equal to 3, and then I can say X is equal to 3 radical 2. If you are not good with 30, 60, 90, 45, 45, 90 right triangles, do not panic. Just use some Sohcahtoa to get this side, and you can bust out Pythagorean Theorem to get over here, okay? So if we're doing the 45, and we're doing Y and 3, we're going to use tangent because it's opposite and adjacent. The opposite is Y over 3. You could use this one and just flip it. It should not matter. We're going to get Y is equal to 3 times the tangent of 45. And then you should be good to go. So 3 times trig, tangent, 45. Enter. Hey, we get 3 back. Look at that, it works. And then we can do Pythagorean Theorem. So a squared plus b squared equals c squared. We'll use this formula because we're looking for the hypotenuse. If you just like using this formula and you want to stick with this formula for all of time, please feel free. This is 9 plus 9, which is 18, is equal to c squared. We'll take this moment to work on simplest radical form. We're going to bust out with a square root. 18 is 9, 3 times 3 times 2. We circle our pairs, we pull that out, and we get 3 radical 2. If you're doing with Mr. Beeman and you work backwards from 18, the largest perfect square is 9, so it would be radical 9, radical 2, and then you just end up with the 3 there. All right, number 11, find the value of b. So once again, we're in a 30, 60, 90. So remember, across from the 30 is x, across from the 60 is x radical 3, and across from here is 2x. So if this is 2x, then this is half of that. So this would just equal radical 3. There's showing your work. We're done. We can go home now. However, as if we're using Sohcahtoa, okay, 30, this is my opposite. That's my hypotenuse. So I can use the sine of 30 is equal to b over 2 radical 3. And now I can just cross multiply and solve. I can also use the 60 and do adjacent over hypotenuse and do the cosine of 60. And it's still going to be the same thing. Please remember that these two things are equal because I added 90, and we should be good to go. Cross multiply. 2 radical 3 is equal to the sine of 30. Okay? And that's equal to b. And then we can just use our calculator here. So 2 control square root 3 times trig sine 30. We're going to go ahead and hit enter here. Calculator typing. And here we're going to get b is equal to 1.732050800757. All right, and we're good to go. Okay. Find the height of the tree. So we got the same issue. We can use the law of sines for this if you want. So this is 27.9. This is 90 minus. And then you can just do like sine of this over this equals sine of that over that. Cross multiply and solve. And we can go from there. So tell you what, let's use the law of sines. We haven't used it yet. So if we do, this is going to be 90 minus 29.7. So if we take that away, we're going to get 60.3. That's the measure of this angle. And then if we use the law of sines, remember it's the sine of, now this doesn't have letters. So if this is A, I can name this B and C, and I can call it whatever I want. So if I'm using A, we're going to do the sine of A over this side, which is A, is equal to the sine of, here we have C, so C over C. So this is lowercase c, that's where lowercase a is, always across from the angles. And then it's the sine of 29.7 over, we don't know, you can call it h if you want, or call it a, or whatever variable you'd like to use. The sine of c is the sine of 60.3 over lowercase c, which is 20. All right? And then we can cross multiply and solve. Now remember, the law of sines has sine in it. If you do not have sines in the law of sines, you are not doing it correctly. It's not a ratio of the angle over the side. It's a ratio of the sine of the angle over the opposite side. We cross multiply. 20 sine of 29.7 is equal to h times the sine of 60.3. Remember, the law of sines works for any triangle. Non-right triangles, doesn't matter, it will work. Okay, that's why it's so important to know, because you can use it in right triangles, you can use it when it's not a right triangle. It's totally up to you here, okay? And it can apply as long as you have the two sides and angles that are always paired across from each other, okay? So just keep that in mind as you're working along. 29.7 over trig. Okay, when we do this, we get to the nearest foot. We're going to get 11.4077 here. So that would just be 11 feet. And there's our answer. Okay. All right. Number 13. Here we go. An airplane pilot spits a lift at an angle of depression of 26 degrees. Please remember, depression is always from the sight at the top down. The problem with this is it's not in our triangle. What we want to remember is we always want to put the angle of elevation or depression in the bottom corner of our triangle. These are alternate interior angles. So if elevation is from the ground up, depression from the top down, we can always put it down here because they're alternate interior. So we're always going in the bottom corner. If you forget this on the exam, it's a half credit deduction. It's considered a conceptual error. So you lose half credit. All right, the plane's altitude is considered 3 kilometers. What is the airplane surface distance from the raft? That's on the surface. That would be down here, D. So if this is 26 degrees, this is 3, we want to figure out this. We're going to use Sohcahtoa, okay? We could also use the law of sines, because this is 90. We can figure out that and do the same thing we did in the last question. But let's bust out the Sohcahtoa. So I know that I'm doing this. There's Sohcahtoa again, okay? Remember how to spell it. You're going to be in trouble here. So from 26, there's my reference angle. This is the opposite leg. This is the adjacent leg. And then I'm picking tangent because it uses opposite and adjacent. So the tangent of the angle is equal to the opposite leg over the adjacent. Tangent of the angle, which is 26, is equal to 3 over d. We're going to cross multiply here. So it's d times the tangent of 26 is equal to 3. Since we're not done yet, we need to divide by the tangent of 26. Not just 26, the tangent of 26. So d is going to equal, and then we just do 3 over the tangent of 26. And we're going to end up with nearest whole number. This is 6.1509, so this is just 6 kilometers. All right, last question. Almost done here, guys. 2 questions left. All right, you went through a professional baseball game, and your favorite player autographed a bat for you. Bat is 34 inches in length. You want to explain the bat in a rectangular case. That's 20 inches long, 12 inches, 28 inches wide, 12 inches deep, and 16 inches high. The deep part we don't really care about, right? Okay. What we care about is that it's 28 inches wide, and it's just telling us that it's like 3-dimensional. So it's 12 inches deep, but it's 16 inches high. So really, if we're looking at this, right, the only thing we care about is the bat going to fit? Like, we can't put the bat this way or this way. So the longest space we can fit it in would be to put the bat diagonally, right, going this way. This way, right? There's my terrible bat for you guys. You're welcome. All right. So will it fit? I don't know. What I need to know is if this is 16 and this is 28, I need to figure out that hypotenuse. Now, it's a rectangular, and that's important. So we know that that's a right angle. And if we're looking for the lengths here, we can just use Pythagorean Theorem. So c squared is equal to a squared plus b squared. C squared is equal to, and now I can do 28 squared plus 16 squared. So c squared is equal to, so if we square everything out, we're just going to get 28 squared is 784. 16 squared is 256. Combine them together, we're going to get 1040, and now we'll take the square root. And I end up with c squared equaling 32.24903099. So will this fit? And the answer here is no, it won't, right? That bat ain't going to fit there, okay? The reason why is our bat is 34 inches wide, so we could say the longest the bat could be is 32.2490, right? About 32 inches to fit diagonally, or diagonally for you Harry Potter fans, all right? In the case, however, the bat is longer than the distance from, you can say the diagonal, right? Corner, let's just say from the distance, and longer than the distance of the diagonal. And that would be enough. So the biggest line in this was going to be the diagonal. It won't fit, so there's no way it's going to work. Okay. Captain of a ship spots a lighthouse at a 47-degree angle of elevation. Right, so let's get our lighthouse going. Looks like a bottle. I have no idea what's going on. All right, terrible lighthouse. Ignore this. Lighthouse with boom. All right. So captain's on the ship. Oh, get ready for this, gentlemen and ladies. Boom. What's up? There's the Titanic sailing through the ocean here, right? Terrible iceberg dead ahead. So angle of elevation, right? Meaning he's looking this way along the water. He has to look up to see the lighthouse. That's our angle of elevation. So 47 degrees goes in the bottom corner. Okay. He knows the lighthouse is 50 feet above the shoreline. How far is the ship to the shore? Okay. So draw and label a picture. Boom, done. Calculate the distance from the shore. All right, let's do it. So opposite, adjacent, Sohcahtoa, and we're going with tangent. So the tangent of 47 is equal to 50, the opposite, over the adjacent, which is x. So x times the tangent of 47 is equal to 50. We'll divide out by the tangent of 47 to get x by itself. And we get x is equal to, and here we're just going to be 50 divided by the tangent of 47. In this case, it's 46 point. Now it doesn't say, so we should write the whole thing out. Remember, test or quiz, I won't ask you to do the whole thing here. So just round accordingly. Remember, it says thousandth, it has 3 zeros. The third number in is in the thousands place. Look at the next number and either decide to keep it or round up, okay? It says, what now if it's 55 degrees? So if we change this to 55, right, we get the same image. This is still 50, but now we want that. So we'll call this y. We've already used x, so don't use the same letter. So once again, we're going to do the tangent of the angle. Now it's 55 is equal to the opposite over the adjacent. So the tangent of 55 is equal to, times y is equal to 50, and then we just divide out by the tangent of 55. And we'll figure out that y is equal to, and then we're good to go here. So 50 over tangent 55, enter. And here we're going to get 35.01037691, which should make sense because as this angle has to increase, it means the boat's going to have to get closer and closer. So that's why this is less. All right, and that's it. That's it for the worksheet. Hopefully you guys went through this all right. I'll include the answers on tomorrow's sheet, and stay warm, people. Don't get frozen.